Let's take another look at an example where we are finding the reflection rule for a shape that's getting reflected over an unknown line of reflection. So what we have here is a triangle with coordinates A, B, and C listed here, and its image, so the resulting triangle after it got reflected, has coordinates A prime, B prime, and C prime here. I forgot the little prime marks there. So what would be this triangle's, or what would be this reflection's rule? In other words, if we were going to describe this as a reflection across some line of triangle A, B, and C that results in triangle A prime, B prime, C prime, what goes there? What is the equation of the line that we are reflecting this triangle across? So that's what we're trying to do here when it says what is the reflection rule. We're trying to figure out what is the line, the equation of the line that we are reflecting this triangle across to get this. Okay? So if we're going to do this, we're going to find this equation. We need to know two things about this line. We need to know the slope of that line of reflection, and we need to know one point on that line of reflection. So we're going to break this down. We're going to look at it in two steps. Find the slope of the line of reflection, then find a point that's on the line of reflection. Now, fortunately for us, this isn't actually too bad, because what we can remember is that the slope of the line is going to be, our line of reflection is perpendicular to all the segments connecting points to their image. So it's perpendicular to segment A prime, it's perpendicular to segment B prime, it's perpendicular to segment C prime, right? So if we can find the slope of any of these segments, we can use what we know about slopes of perpendicular lines to find the slope of the line of reflection. So let's look at finding the slope of, line A prime. Now we know that to find the slope we're going to do y2 minus y1 over x2 minus x1. So the two coordinates I'm going to use are this and this. So I'm going to say negative 2 minus 4, right? So that negative 2 right here is the y coordinate for A prime, and the 4 is the y coordinate for A. And then I'm going to do negative 4 minus 2. Again, this negative 4 is the x coordinate of A prime. This 2 is the x coordinate of A. So that's going to give me negative 6 over negative 6, which is a slope of 1. So if my A prime segment, right, if this segment here has a slope of 1, then the slope of the reflection line, the slope of the line of reflection, would be negative 1. So now the next thing I'm going to do is I'm going to find a point on my line of reflection. And what I need to remember is the line of reflection, this guy, goes through all the midpoints of the segments connecting the vertices to their image. So it goes through the midpoints of A prime, of B prime, and of C prime. So if I find any of these midpoints, that would be a point that's on the line of reflection. So let's find the midpoint of A prime. Okay, we're going to find the midpoint of segment A prime. And to do that, we are going to take the x coordinates, add them together and divide by 2, and then we're going to take the y coordinates, add them together and divide by 2. So that's going to look like 2 plus negative 4 over 2 and negative 2 plus 4 over 2, which would be negative 2 over 2 comma 2 over 2, which is equal to negative 1, 1. So now this point is on my line of reflection. So if I'm going to write my equation, I'm going to go ahead and write it in point slope form. So I'm going to say y minus y1 equals m times x minus x1. These x1, y1 points are going to be any point on my line, so I'll use this one. M is going to be my slope. So then I'm going to say y minus 1 equals negative 1 times x plus 1, because it says here that we are taking minus the x coordinate. Well, the x coordinate that I know for the point on my line is negative 1, so when I subtract negative 1, it's going to turn into positive 1. And then if I simplify this, it's going to say y minus 1 equals negative x minus 1. I just distributed this negative 1 in there. And then if I add 1 to both sides, that's going to give me a line that's called y equals negative x. Okay, so let me just scooch this up a little bit. This is my equation for the line of reflection. So my rule says the reflection in the line y equals negative x of triangle ABC gives me triangle A prime, B prime, C prime. There's my answer.